I thought I would give you a little bit more insight into some of the delta math examples you may see, because there's actually a lot of things that could possibly happen when using law of sines, specifically when you're finding a missing angle measurement. So let me walk you through that. For whatever reason, delta math chose to use different letters than your formula provides. Not a problem. You're still using law of sines. It's just not A, B, and C's. So what we would want to do is we want to find missing angle F. So we're going to have to use the only thing that we do know that's opposite of each other, and that is angle E and side E. And then angle F is what we want, side F is given. So when we set up the problem, it's going to look like sine of 149 over 30, those are your E's, and sine of F over 93. Cross multiply and divide by 30, and you end up with this. Remember that when you're finding an angle measurement, you're also then going to take the inverse sine of both sides of your equation. And this particular time, you're not going to get a solution. It says something like domain error in your calculator. And so what that means is that there are no triangles that you could possibly draw that have these angles and these side length measurements. Second example, so on this one, I'm looking for angle K. I know M and I know M. So I did sine of M over M equals sine of K over K, which would look like this, 160 over 360. Don't know K, but over 380. Cross multiply and divide by 360. Take the inverse sine of both sides. I got a little bit lazy with my work and kind of skipped a few things over here, but hopefully you're seeing that it's exactly the same thing as before. Inverse sine computation, you get 21.162. Okay, now 21.162 would be the angle measurement right here. Please don't stop at this point. There's one more thing that you need to do to check your work, and that is you need to find angle L. So to find angle L, remember what we were doing before is just do 180 minus the two angles that you have. So we have 160 and 21.162. What happens when you do 180 minus 160 minus 21.162? You get a negative angle measurement, don't you? You get negative 1.162. Okay, what does that tell you? That tells you that this angle is negative degrees. Well, that doesn't make any sense if you're trying to draw a triangle, okay? So what that means is that this measurement is actually not going to work in this triangle. Therefore, there is no possible triangle with these measurements. Okay, so this is a tricky question because the last example I showed you, the calculator said no, domain error wasn't going to work. This time you did get an answer, but it's going to require you double checking that solution to make sure that it actually works. This is kind of like an extraneous solution in trig or geometry. Okay, here's another one, setting it up in a similar way. I chose to do sine of G over G, sine of H over H, cross multiply, inverse sine. So all these steps are, what we've seen over and over again. And you get H equals 14.33. All right, so we're going to throw that here, 14.33. And we're going to check our work. So if I try to check this angle measurement, F, 180 minus 151 minus 14.33, you do get an angle measurement. Therefore, this triangle, it is possible to draw it with the given information. Here's the last example. So we've got it set up. This is sine of J over J, sine of H over H. Cross multiply, inverse. All right, so here's what we get. We get H equals 51.88 degrees. That's this guy here. Okay, after that, we're going to check and make sure that I is actually computable, and it is. You get 84.12 degrees. Now, This one has a catch, and it's not something that you're going to always recognize, all right? But in this particular problem, we need to consider that sine is a positive number in quadrant 1 and in quadrant 2, okay? Inverse sine doesn't really take that into account. When we do that computation in the calculator, inverse sine only gives you the result that's in quadrant 1, but there is another possible solution, and it's in quadrant 2. So let's go back for a moment. When we found that h is 51.88 degrees, find what this angle would be if it were reflected into the second quadrant. So kind of like its counterpart in quadrant 2. To do that, you would do 180 minus 51.88. And that would give you 128.12. So I am saying that it is possible for h to also be 128.12. Here's why. When you go and check the angle that you're given and this new angle that we just found, when you subtract those two values from 180, you get 7.88 for the other angle measurement. And since all three angles, the 44 with these two red angles, add up to 180, that means that there's two possible combinations of angles that actually would produce the same side length measurements. So there are two possible triangles that you can draw with this given information. All I'm going to say to you is that it's not real obvious why there are two answers here. My suggestion would be just to do this extra little bit of work every time to make sure that you're not missing something, okay? You only have to do the extra work, by the way, if you do get one answer to work, right? If you're getting something where, this isn't possible or this isn't possible, there's no need to do the additional work.